All right, so 105, I'm going to get started. This is COMP2404 Introduction to Software Engineering. And I'm Darrell Hill, your instructor, now with improving voice. So today is November 22nd. We're still slightly ahead of where we would want to be, I suppose, but that's not a huge deal. So you've submitted your assignment 3 and you're working on your tutorial 8. And tutorial 9 and tutorial 10 are already released, as is assignment 4. We revisit some old classes and sort of implement them a little bit differently. Yeah, as far as your exam goes, so they want me to submit by this Friday, which means I might just go with pure multiple choice. I had wanted to put some handwritten programming questions in there, but writing an exam is easy, or making an exam is easy, but proofreading it is hard. And I may not have time to proofread it to the level that I would like. So I might just reuse some of the multiple choice questions that I already have. Right, if I make a mistake in a multiple choice question, oh well, you guys get the mark automatically. If I make a mistake in a programming question, and that's kind of a big deal. So we'll see what happens. I don't know. It's a busy week for me, but it may just be, maybe 45 multiple choice or something like that. Now they'll be tricky. They're not easy. They're meant to, I don't want to say tricky, but they are kind of a little bit tricky, some of them. Some of them are really easy, but yeah, it's meant to make you think about how you programmed in C++. And but anyway, so yeah, I'll let you know this Friday or next week, I guess, what kind of exam you guys are having. But all right, any questions on the schedule or anything like that? Okay. So last class we were talking about operator overloading, and we will this class. We might get into templates, but we'll see. Specifically, we left off last class looking at collection classes. So we built a bunch of collection classes at this point. And operators are sort of a natural match for them, right? So the subscript operator, for instance, is quite useful. It's implemented on vector and, of course, arrays. So the nice thing about it is if you implement subscript on your collection class, then there's a bunch of, let's say, algorithms that can use collection classes that use subscript operators or these other operators that now you can use with your class. So we'll see algorithms a little bit later in the course, but so last class we had left off looking at the book array class. So well, it's not that's fine. So yeah, we had a book class that's basically just an entity class. It has a few, a couple of members. What the hell? Okay. Anyway, there's a couple member variables. So I have my other computer here because it works better with, you can never get something that's completely going to work for everything, but all right. So you just work around, the limitations, but it's just an entity class that has a couple of these member variables and some getters for the member functions. And otherwise it just holds some information. No big deal. So then we made this book array class. We overloaded the output stream operator, and we should, it's a good idea to always, I guess, use this const here and anywhere that we need to, because otherwise it can come back to haunt us. So the OStream operator, I recommended, putting through a virtual print function. So if the print function is const, actually that doesn't matter, but it does matter for the subscript operator. So in our virtual print function, so yeah, in our stream insertion operator we call the virtual print function. That virtual print function then just takes this OStream operator and basically prints our books to the OStream operator. What we use for a backing array is simply an array of book objects. So not pointers, but objects. But yeah, so our this is a pointer to an array that is on the heap. It's an array of book objects, which means that yeah, so we dereference this to get back the book array object, and then that calls on this subscript operator, which then returns my book to be printed out. Okay, so that's where we got to last class. The little problem we ran into was that our original subscript operator didn't work in here because this is a const function. So in some sense, I'm calling a non-const function from a const function. So this gave us an error. How we went to improve that is that we overloaded this subscript operator, which is basically par for the course. So if you make a subscript operator for your collection classes, you generally make two of them. One that, where I can do things like modify, I can assign it a different book, for instance. I can return, I can get back a book and I can make changes to that book. But if I want to print out my books in a constant print function, then I also need this other version of the subscript operator. So it's it's a promise to not change the underlying book array, and I return a const book reference for good measure. So this is a reference to a constant book. So yeah, these two things in tandem are going to handle most of the subscript cases that you'll run into. So then in my main function, I made a book array with size 7, and then I made 5 books, and I assigned 4 of them to my array using this subscript operator, right? So this would call the non-const version of the subscript operator, because I am making modifications here. And then I printed out a couple of them, and then I called print on the entire array. So let's just see what that does. Okay, so did I forget to save something? Or maybe I'll just clean it. Oh yeah, so so the one thing I didn't do actually is I made the, yes, I used the made the function prototype, but I didn't make the actual function. So basically what I want to do is the same thing here, but I'm going to say, oh my goodness. Const book and const. Okay, so now I have 2 versions of this subscript operator, one for when I need to make changes to the book array, and one for when I'm calling the subscript operator from a const function. Okay, so I print out the 2 books in my book array. Here and here, that's in this line here. And then I print out the entire array. Where do I do that? Right here. Starting at array 1. And so all right, sorry, I'm just going to, this little setup is not really working out. To go to manual mode here. Okay, so yeah, array 1, this is where I print out the entire array. And then I printed out these 2. So the subscript works with the cout the stream extraction operator, and my print function also works. Okay, so now what else do we want to do with our book array class? Well, we might want to say, again, if we do our sort of test-driven development, I can make a new array, array2. So let's make book array R2, and we'll make it size 10 or maybe size 4. Let's do that. Okay, so now I can print out array 2, and then I can assign array 1 to array 2. And then what I want to do is I want to be able to compare these two arrays. So there's a couple things I want to overload. So one is, this is just an assignment operator. What it does is a member-wise assignment. So let's take a look at my members. So I have basically a book pointer that's pointing to an array of book objects on the heap, right? So that's this book pointer is doing double duty in that sense. I guess I could draw it here. So yes, I have a book pointer, and then on my heap, I have an array of book objects. So when I do a member-wise assignment, right? So if I just use the default operator here for the assignment, it's going to do a member-wise assignment. The member is a book pointer, so it's just going to copy that pointer address. That is not the behavior I want in my collection class. What I want to do is make a new array that's the same size as the old array, and copy all the elements over. Right? So is that sort of clear why we're doing that, or what's going to happen if I don't overload the assignment operator? Okay. So this returns a book array reference. So we want to enable cascading whenever possible. Operator equals. And this will take another book array reference. And we should make this one const. Right, we're not going to make any changes to this one. So this will be the signature of our assignment operator. Okay, so now if we look back at our little diagram, what we originally did is we had a book array. It had a book pointer, and if we invoked the assignment operator, then we have another book array, array 2, with another book pointer, and that's just pointing to the same thing in memory. So now what I want to have happen instead in my assignment function is I want to make a new array. I'm going to look at the size of the old book array. I'm going to make one that matches exactly, and then I'm going to copy all of these elements over and have this book pointer point to that array, right? So this is my book array class. This is the pointer to the backing array, as is this. So I want to do a deep copy of these elements. Not really a deep copy, but at least deep in the sense that I need to make a copy of the array itself and then copy all the elements over. Okay, so what did we call that? Elements. So elements equals new book. So it's an array of book objects, and the size is going to be BA dot, what do we call it? Num elements, maybe? What did I call it? Capacity. Okay, so I've made a copy of the array here, and then I want to copy all the elements over. So we'll say 4. I, and then I'll say elements at I equals BA elements at I. Right, so I'm just now I'm using the default assignment operator for my book class, but that works fine because I don't have any dynamic memory in my book class. I have a bunch of static members, and if all you have is static members, the default assignment operator works fine. Right, it's only if somewhere in my, let's say, constructor or somewhere else, if I have a new statement, then I probably need to do overload this assignment operator. The last thing I want to do is make sure my capacity is correct. All right, so I've overloaded the assignment operator, and now I should be able to, for instance, assign array 2, assign array 1 to array 2, and then maybe print out array 2. Okay. Let's, so that we don't get a lot of extra stuff being written to the screen, let's just make it a size 4. So we are only outputting the 4 books that we have. All right. They do now. Implicitly declared const book array operator. No, this one's not saved, of course. All right, so we got some warnings, but no errors. Okay, so I print out the first 2 books. I print out array 1. It has these 4 books. And then I print out array 2. So I initially make array 2 of size 4. It has a bunch of unknown because it's just these are the default books. Then I use the assignment operator here. And now you can see my array 2 is matching my array 1. Okay. Questions on any of that so far? I know there's a lot of concepts being thrown around. So what mistake did I make? Because I have a memory leak here, right? I believe. Let's see. Yeah, I definitely lost some memory. So, anybody spot the memory leak? So if I look at my diagram, what I did is this book array already existed and already pointed to here. When I made a copy of it, what I did is I made a new array. I copied these items over, but I left this guy in memory. So I have to delete the old array that I was pointing to. So I should say, and that should take care of any. Yeah, definitely lost. I think I forgot to put a, so yeah, the other memory leak is, oh, I deleted that. New book. Still have a memory leak somewhere for some reason. $15 Alox, 15 freeze. In use at exit 296. Sorry? In the assignment operator? This one here? No, so the memory model is this. This is kind of messy, but on my heap, I have my book array class. And then I have a book pointer that points to an array of objects. So when I delete that array on the heap, each of the objects, these are not pointers, these are actual objects. So the destructor is called on each of these books. So I think that is not where the leak is, although this is, I'm not going to spend too much time on it, but let's take a. Which one's that? Oh, yeah. Ah, thank you. Yes. Oh, okay. Yeah, that's a common mistake that I always make. Thank you guys very much. So yeah, let's try that again. Oops. Oh my goodness. All right, so all heap blocks are freed, no leaks are possible. All right, great. Thank you guys very much. So we solved that little memory leak problem. There's still an error there apparently, but I didn't save it. So okay. Good. Questions? Okay, so the other thing we want to be able to do is take a look to see if two arrays are equal. So how am I going to do this? I want to, so if I just use default double equals, but basically I want to go through each array, each backing array in my book array, and I want to check that each member matches. So the first element in array 1 matches the first element in array 2. And the second element in array 1 matches the second element in array 2, etc. So bool operator. Okay. Okay, so I'm going to loop over each array. First of all, I can check to see in this instance, of course, if the arrays are different sizes, if the backing arrays are different sizes, then they are not equal. So if capacity is not equal to BA.capacity, I'm going to return false. Otherwise, I have the backing arrays are the same size, so I'm going to just loop over them. Equals 0. And then I'll say if, and basically I'll loop over every one. And if a single one doesn't match, that means they're not equal. So I'm just going to check each one elements. Yeah, okay. We have an equals function in our book class. No, so I should write that as well. So I want to write yeah. Okay, so the assignment we got for free, but I want to write this actually, this not equals operator. Not equals const book and okay, so how do I know if a book is not equal to another book? Well, either the I'm just going to check the title and the author. I don't care about the ID necessarily. Or do I? Yeah. In this case, we'll just look at the title and the author. So I'll say return title equals b.title, which I can do because title and b.title are strings, and these are overloaded for strings, I think. Let's say, right. Sorry. We want to do, actually, we want to do or. So title not equal to b.title or author not equal to b.author. If either of those are not equal, then this returns true. So that's our not equal operator. Okay. So now we have something we can use here. So if elements is not equal to va.elements, I'm going to return false. I don't have to do any other calculations. If I happen to get through the entire both arrays and each of these comparisons returns false, I guess, then I'm going to return true here. Okay, so in order to be true, I have to go through and all of these elements have to not be not equal, essentially. And also the arrays have to be, the backing arrays have to be the same size. All right, questions on that? Okay. So now in my main, we can see that I ask, is array 1 equal to array 2? Yes or no? I have just assigned array 1 to array 2, so they should be equal. I'm going to get rid of this so we don't have that extra noise. Make sure I save everything. All right. Okay, what did I do? Not equal, and then the book array. I have equal. What's that? Sorry? Oh yeah, that's one problem I did have, yes. That shouldn't produce an error, but yeah, thank you. I think the problem was, again, I forgot to save my book array.h. But yeah, thank you for catching that. Okay, so it's looking good. So yeah, are they equal? Yes. You can see here, you can look at it and see that they're equal. I didn't change the IDs. I could have, I suppose. Yeah, I just checked the title and the author, and if the title and author are equal, then the arrays are equal. Oh no, sorry, it did copy the IDs. So yeah, that's the default member-wise assignment for the book class. They copied the IDs over. So array 1 and array 2 are equal. All right. Questions? Okay, so these are particularly useful for collection classes, these operator overloads, but you have to be careful how you implement them, because now you have basically, a data structure that contains a lot of other objects. So what does it mean for that data structure to be equal to some other data structure? Well, you kind of have to decide, right? And how we decided is we said that everything had to match, everything that was contained had to match. So yeah, these operators are particularly useful on collection classes, but we have to take extra care in implementing them. They're a little more complicated. All right. So yeah, a couple other things we could have implemented: plus equals, minus equals. I believe I may have asked you to do that on your assignment 4. I'm not sure. I think I did. And in my data class, my entity class, if I want to have a sorted collection, for instance, which we're going to see a little bit later when we look at the vector class, we of course want to overload these operators, in particular the less than. Yeah, and then a review of the example we just did in our book array class. There is a default assignment operator, but it just does a member-wise assignment, which is a shallow copy, which presents a problem because now I'm just copying the address of the one array, the backing array of B1 into the pointer for book array B2. So now both book arrays point to the same array in memory, and that is, in this case, not what we wanted. So, for collection classes, assignment, equals, and things like that, you may want to overload them. It's a good idea. Okay, so that brings us to these increment and decrement operators. So this plus plus I plus plus, I minus minus, plus or minus minus I. So we have lots of different variation, right? We have increment or decrement, and we have prefix or postfix, and they can be global or member functions. And each has their own syntax. So we're going to take a look at all 4 of those examples. So if we have a prefix plus plus or minus minus, right? So this is the prefix version, plus plus I, for instance. What it does is it modifies the operand and returns a reference to the updated object. So the operand here is the I variable. So it adds 1 to the I variable and then returns that variable. So if we implement this as a member function, then it takes no parameters. If we implement it as a global function, it takes 1 parameter, and that's the object to be modified. So we will look at this, I believe, with the time class. All right, so we have, yeah, good old time class. And yeah, just vanilla time. So now we want, so what we're going to do is we're going to implement these plus plus and minus minus operators, these increment and decrement, but we're going to compare the behavior with the int class. So as we talked about, basically you want your classes that you make, when you overload an operator, you want it to behave the same as an integer. Right, so we're going to see how int behaves here. So we start with int 10 equals 10. We print out the original int. We use the prefix increment, and then we print out 10 after. So let's see what that output is, and then we want to reproduce that result with the time class. So T9. Okay, so the original int is 10. I use the prefix operator in line with the stream insertion operator, and I get 11. And then after that plus 10, I still have 11. Right, so this changes 10 and returns it right away. So that's what we want to do in our time class, which is just complaining and complaining. All right. So we're going to do the increment as a member function, and then later we'll do the decrement as a global function. So again, we want to enable cascading, right? So this returns something, this returns in this case, an int. When we do it for the time class, we want it to return a time object. Right, so this, using our test-driven development again, we write our tests, we see where the error is, and now we're going to fix it. So we want to return a reference to a time object. Plus plus. The operand is the this variable, so this is all we need for the plus plus member variable. Okay, so let's define this behavior, I guess. So what does it mean to increment the time object? Let's say we add, should it be 1 second or 1 minute? I think we can do, let's do 1 minute, I guess. So I want to increase the minutes by 1, and then I want to, but I also want to make sure that I just have a set time object, eh? So let's just do it the easy way then. I'm going to say int time equals convert to seconds. And if I want to increase it by a minute, I'll say plus 60. And then I just say set time. Right. Just doing perfectly lazy, reusing other functions. So yeah. And then I want to return this object. Since I am returning it by reference, I have to return the object itself. I have to dereference my this pointer. All right, so yeah, any questions on that? Okay, so now I have, yeah, so the error has gone away, but let's see if it behaves the same way as my int. Okay. So my int, the original is 10, and then when I use the prefix operator, it's 11, and then after I use the prefix operator, it's 11. My time is 12:28. After I use prefix, it's 12:29. This is inline in the cout stream insertion operation, and this is afterwards. So I have the same behavior in time that I have for int, so I'm happy. This works as expected. All right, our next test, let's do yeah, we're going to do a prefix decrement operator. This time we're going to implement it as a global function. So let's see the behavior for our, let's get rid of this. Okay, so this is the behavior we want. My original int is 10. After prefix inline prefix decrement operator gives me a 9. And then after that operation, I still have 9. So now my original time is 10. I want my decrement to print out 12:27 and then to stay 12:27. But again, I'm going to do this as a decrement operator, which means it's going to be a global function. I want to have access to this private convert to seconds operation so I can make my life easier. I'm going to make it a friend. Returns a time reference. Minus minus. And now I have to explicitly supply this, this argument. In this case, I do not make it const because I do want to make changes to this, this time variable. Okay, so I declared it a friend. It's a global function. Now I just have to write it. Let's write it here. Okay, so I don't want this scope resolution operator since it's global. I want time and t. So int time equals t dot convert to seconds. And now I want decrement, so I want this to be minus 60. And then I'm going to say t dot set time. And then instead of returning this, I'll just return t. Okay, so the logic is very similar, but of course now I'm doing all of my operations on this parameter instead of just this. All right, so let's see if there are any questions on that. Okay, let's see if that works. Nope. Private within this context. Did I forget to save? Yes. Oh, yeah. So, sure. I have to actually run the test as well. So here's the test. Okay, so I have 1099 and then I have 1228, 1227, and 1227. Okay, so my decrement operator works the way that I want it to. These are prefix operators. One implemented as a member function, one implemented as a global function. Yeah, typically you want to implement it as a member function, but any questions? Yeah. Sorry? Sure. This or the decrement? No, I just it's up. What did I do here? I think I accidentally deleted a test, maybe. There we go. Right. So that's, sorry, that's it. Good. Okay. Other questions? Okay. So yeah, that's the prefix operator as both a local and a global function. So now we have a postfix operator, and I mean, it looks basically the same. So we have this I plus plus, or, you know, I minus minus, but in terms of, you know, how I write my function, there's no difference. So they really did a sort of a strange thing here. Instead of changing the function signature, which to me, maybe is the most sensible solution, they introduce a dummy parameter. So they supply an extra int parameter. It is an actual parameter. You can use it if you like. But technically it serves no purpose. There's no input that goes through there. It's just to make the function signature different. Right. So again, we saw when the compiler mangles a function name, and it sort of takes the function name and puts the parameter list on it in like some code. That's the only reason this int parameter is there. Okay, so the signature is different. Also, the implementation is a little bit different, right? I have to make a copy of the object before it is modified and then return that copy. So I don't want to return the reference itself. So, well, let's take a look at this example and then we'll talk about it. So we'll see, first of all, we'll see how it's implemented in the integers. So now I want postfix plus plus. I can okay, so my original int is 10. I put it to the, you know, I put it to the standard output using the expression 10 plus plus. So what this does is it returns the original value of this 10, but then it makes sure that the 10 is incremented for when I print it to the standard output here. So original int is 10. This is 10 plus plus, still returns 10. But the next time I look at this variable, it has a value of 11. Okay, so that's the postfix operator. And I want to do the same thing for my time class. But right, so I'm going to have to, of course, since I want my time class modified, I can't exactly return it. I want to, but I still want to return a time object. So I'm going to make a temporary object and return it by value here. Again, if I make a temporary object on the stack, it's a terrible idea to return it by reference, and you will get a warning from the compiler. In this case, you want to return by value. You want to make a copy. Okay, and as promised, we're going to add an int here to tell the compiler, look, this is a postfix operator. Okay, so let's take a look here. Okay, so again, I want to do something like this, but I still want to, I want to make a time object first. So I can do something like this, time temp equals this. So I can simply rely on the default assignment operator. There's a bunch of things I could have done in this case, but yeah. So this will, sorry, this is not the assignment operator. This is the copy constructor. But since my time object does not have any dynamic memory, the default copy constructor is going to work just fine. So I make a temp time object, and then I change my time the same way as I did before, and then I'm going to return this temp. Oops. There's one sensitive pad. All right. So yeah, I make a temp object that is the current time. Then I change this current time the same way as I did before, and then I return the old time. So this should work. We go to now plus plus. Yeah. So we have the same tests as the same tests as oh, I didn't make it. Error. No operator declared. Oh. Yes, so I didn't save it. So yes, no operator declared means there's a problem in the header file. Okay, so with postfix, I get 10, 10, 11. With postfix on my time, I get 12, 28, 12, 28, and then 12, 29. So that is the behavior that we want. It's a little bit wasteful. We make an extra time object. And then this time object gets returned as an R value. Right, so here, this time object that we made gets returned, and the compiler keeps it alive long enough for you to send it to cout, basically. But if I don't assign it to anything, it just disappears. Actually disappears no matter what I do. What I can do is copy it into another time object. But yeah, so the postfix operators are actually less efficient than the prefix operators. It's a small difference, but you know, when you're running for loops and things like that, it can, you know, have an impact on performance. Questions? Yep. Nothing. Just for the function signature. So because I have two function names that are exactly the same. One returns a time reference, one returns a time object by value, but the compiler doesn't know what the return value is when I call it. Right. So if I call plus plus I or I plus plus, the compiler does not know which of these two to call. So that's why we have the dummy parameter there. It just says this is a postfix increment. How can they identify? Well, okay, so the compiler goes through and it says it sees now plus plus, and then it looks for something that has an integer as a parameter. It looks for something operator plus plus, and then it has an integer as a parameter, right? So if we go back to here and we look at this is the mangled function names. So this is double num, and then I is for an integer parameter, and P is for a pointer, and I is for a, so it's an integer and then a pointer to an integer. So that's how the compiler tells one function apart from another. So
override this operation, so you should obey this rule.
you would rather, you want to override it so you do something different?
Anyways, I just confused about like why we're writing this way, but not out of there.
You're confused about why we're doing this?
So we basically just like rewrite the function, like override the function, and we should follow the parameter right now.
Yeah, we rewrite the function and we throw in a dummy parameter so that it's, well, I mean, so I'm not sure what exactly you're asking, but like both the prefix and the postfix have their uses, right? So they can be useful. But the compiler can't tell them apart. That's the problem. It's, I mean, if you're saying it's a dumb solution, I completely agree with you. But maybe they had a reason for doing it that, you know, we didn't anticipate. It seems like they could have done something different. Yeah. Other questions? Okay. So now we want to do a postfix decrement. So let's see how that works on our int. So int postfix. So when I say 10 plus or 10 minus minus, and I send that to cout, it returns the original value, which is 10. But then the next time I access the 10 variable, it's decremented to 9. So that's the same thing I want for this time variable. However, I'm going to do it as a global function, not for any particular reason, but just to see how we do it. Okay, so it's going to be the same as this, except again, I'm going to have a dummy parameter, but so now this decrement operator will have two parameters. I want to return a time object. Let's see if I remember. Does the int come first or second? We will see. Extra parameter of postfix must be of type int. Okay, so second. So that's why I like having that, the inline error checking. So you can do little experiments like that without having to compile everything. Okay, so now my function signature looks like this for the global function. It's a friend, so I can access all the private members. And then I'm going to basically do something very similar to this decrement operator. Except now I want to make, again, I want to make a temporary time variable that I return. So time temp equals this. And then I can just copy all of that. I'm not sure. This may only be used inside of not. Oh, yeah. Sorry. Should be T. Yeah. So time temp equals T. I make a temporary time variable. I increment the time variable that I passed in as a parameter. In fact, I could do this. And we'll come back to that. Okay, so this should work as advertised now. So we'll go here. Postfix decrement operator. Okay, so 10.10.9 is the behavior for my int, and then 28. Oh, no, it's not working at all. What did I do? I returned the wrong thing, didn't I? Return T, I should return temp. Okay, so yeah, 10.10.9, and I got 12.28, 12.28, 12.27. So this is my postfix decrement operator working as specified. All right, questions? Okay, and I never did use this dummy variable, but I could have. I could say dummy equals T dot convert to seconds. And then I could say time temp dot set time, or is that private? Shouldn't have. So dummy, and then return temp. So this dummy variable is, even though it's a dummy variable, it does actually, we can use it. So 10.10.9, 12.28, 12.28, 12.27. Okay. So that's increment and decrement, prefix and postfix, and implemented as a member function and as a global function. Right. So questions? All right. So yes, this postfix creates a temporary object, which makes it slower. Now, of course, there are use cases for that, right? So if I'm adding to the back of an array, I can do something like this, size plus plus. So it returns the original size of that, and then it increments the size variable at the same time. Right, so this is, it is useful. We pay a little bit more for it in terms of memory allocation, CPU cycles, but it's not, you know, so don't use it if you don't have to, but if you have to, it'll be fine. Okay, so if this postfix increment and decrement, if it's a global function, it takes two parameters. So the first one is a reference to the operand, and the second one is a dummy int variable. And again, I'm sure they had their reasons. You know, it's easy to criticize the people who actually built the language, but I'm sure there was some reason, or maybe not. Maybe it's just a dumb mistake. If it's a member function, it takes only one parameter. That's the dummy int. Yeah, I mean, mistakes are made. I was just reading about I'm reading up on Rust, which is like another systems language like C++, but it's supposed to be memory safe. We'll see how that goes. But yeah, one of the people who designed C and C++, they were considering whether or not to make a null value, right? So that you can assign a dangling pointer to this null value. And he said, they say it's this $10 billion mistake because so many errors have arisen because of this concept of null. Anyway, so yeah, maybe it was a good idea. Maybe it was just a bad idea. Who knows? All right. So yeah, the last thing we're going to look at with operator overloading is something memory management, of course, is difficult in C++. This is sort of true of almost any systems language. Again, Rust tries to make it so that it tries to force you to do smart things. But, you know, it could actually get in your way. You know, you don't want something that makes it too difficult to program. Anyway, in modern C++, there are helpful tools like the smart pointer and reference counting pointers. So we're just going to look at a simple implementation of a smart pointer. So we can make that because we can overload these operators, the arrow operator, the dereferencing operator, and the address of operator. So if we overload this, we can sort of intercept a call to a pointer and then do something that we like. And then, so we can have a class that sort of wraps up our other classes and then deletes them when they go out of scope. So we're going to make a class that acts like a pointer. Okay, so yeah, we have our good old time class. We have a main function. So we just, let's just make sure everything's up and running. CD. Okay, so it prints out my time and then, yeah, I should be using the stream insertion operator, but being lazy here. So what I want to do is, well, the first thing we're going to do is we're going to overload the arrow operator for our time class. So when we overload the arrow operator, what it expects back is either a pointer, well, basically it expects something back that also overloads the arrow operator. So a pointer is acceptable. So there is no real reason to do this other than to show you how this works. And then we'll make our smart pointer class. But I'm going to override this arrow operator. This takes, yeah, I did. All right. This shouldn't, yeah. So again, I want to return either a pointer or another class that overloads this arrow operator. So basically there's this cascading effect when I use it. And then, well, I'm going to make an inline function here because it is quite simple. So all I'm going to do is say return a time pointer. And the time pointer I'm going to return is this. Okay, and then just to make sure that this is working, I'm going to put a little bit of output graffiti. All right, so I was here and I'm going to return the time pointer. So what does this look like in practice? Well, now my time is an object, but I can use this operator and then I can call, it returns a pointer to a time object. So I can call print on that. So I can basically use this time object the same way as I would a pointer. Okay, so let's do a little bit of formatting. From arrow. Okay, so printing from the, so yeah, printing. You do another end line here. Okay, so printing from arrow, it's printed out, but it also says I was here. So we did actually override the arrow operator. We returned a pointer, and then this print function was called on the pointer through basically an arrow operator. So the compiler just basically repeats this call to the arrow function. All right, questions so far? Okay, so we're going to make a class called sPointer.h. And this is going to be a smart pointer. So what a smart pointer does, well, let's write the code and then see if we can make it work. So I want to make a sPointer SP equals new time 10, 10, 10. So I'm going to assign it a new time pointer. And what's going to happen is when I leave this function, since this is statically declared, it's going to call the destructor of the smart pointer class. And in the destructor, I'm going to automatically delete this time variable. Okay, so well, let's start by doing this time. Printing SP. Okay, so printing SP, I was here. Yeah, all right. So file grind. But I didn't delete it and I lost memory. So what I'm going to do is make this my smart pointer. And I want all of these same operations to apply. So I want to have I'm going to do all of these in line just to save time. But I want to have a constructor. This constructor is going to take, in this case, a pointer to a time object. And then here, so I want public. Okay, and then so T. So I'm going to initialize it with this time pointer. I also want to have a destructor. And all this is going to do is make sure that I delete T. The other thing I want to do here is, just to be safe, I want to assign it null by default. So I can safely call delete on a null pointer. Otherwise, I should send in something sensible. So if I make a S pointer that isn't assigned anything, then yeah, it gets assigned null. I also want to overload this S pointer operator equals. So if I assign it a time pointer T, I want to say this. Okay, so I want to overload the assignment operator. And then the other thing I want is the dereference operator. So I want it to behave like a pointer. So if I dereference it, I should be able to print. So dereference returns, should return a time object by reference. And then here, all I want to do is return a dereferenced T, right? So if I dereference my smart pointer, it should behave like a time pointer and return the time object, which is what I do. If I assign a pointer to my S pointer, it's going to tuck it away in my member variable. And then whenever this S pointer goes out of scope, the destructor is called and I delete my time object. So this is sort of the basics of a smart pointer. Yeah, questions? All right, so let's see if this works. So I make a smart pointer, a new time object. I can print my smart pointer. I'm going to actually get rid of these. Oh, yes. That's the one thing I didn't overload is the arrow operator. So that returns a time pointer. So that simply returns T. Okay, so now this smart pointer class behaves exactly like a pointer in all the ways that I want. So I can, for instance, call print on it. And return this. What did I forget? H23. Oh, yes. Return this. The compiler was going to fix that for me, but really? Okay, so printing works as expected, and then if I run it with Valgrind, you can see that I have no memory leaks. I can also use the dereferencing operator to print it again. And so I can dereference my smart pointer. This returns a time object, and then I can call print on it. All right, so I print SP twice, once from the arrow operator, once from the dereference and dot operators, and it's memory stick. So that's basically when you use a smart pointer in C++, that's what you're getting. It's not that complex. There might be a few other things to pay attention to, but question? Yep.
Would you have to use multiple if you needed more than one for the class? Or would you pass separate arguments?
Right. So if I wanted to use something other than the time class, you mean? Yeah, so we're gonna actually, when we get to templates, we're gonna come back and we're gonna make this class into a template class, which means that it's sort of like generics in Java. So we'll be able to say, using the angle brackets, we'll say what type of data it's going to point to. Yeah, so we are going to do that. And yes, you can. That's coming up very short. Other questions? Okay. All right, so 8 minutes left. That takes us to the end of overloading. There's a lot. There's even a lot more you could do there, but we won't go too far down that road. So that brings us to templates. As mentioned, we'll just, I'm not sure what, how much do I have here? Right, so we're going to talk about, we're going to give an overview of templates. We're going to talk specifically about function templates. So just global functions, how we can make them into templates. Then we'll talk about class templates. So these are like generics in Java. And then we're going to talk about the vector class. So, I mean, what is a template? Well, it's right. So technically we want to, you know, as just mentioned with the smart pointer, what if we want to use that with some other data type? Well, this is what's known as data abstraction. I have a bunch of logic there that should work for any data type. All I have to do is basically do a find replace on that time, right? So if I did find replace time with student, now I have a smart pointer for students. And that is essentially what templates do, except we have the compiler do it for us because the compiler is better at it. So this promotes code reuse. I can reuse existing code in your programs. You can make your classes reusable. In particular, collection classes are, you know, the most often templated classes. So other mechanisms for code reuse, use existing libraries. They're generally well made with few bugs and very efficient, right? So the vector class, for instance, you're unlikely to find too many bugs in that class. It's been looked at and used over and over again. And when things are widely used, all of these bugs are found out pretty quickly. The other mechanism for code reuse in C++ is this generic or template programming. So we're going to write general algorithms that can be applied to multiple data types, like the smart pointer. So it's called generics in Java and templates in C++. Of course, everything's named differently in C++, but the reason it's called templates actually though is because when I write a, let's say, templated class, it's not actually a class. It is basically a blueprint for the compiler to make a new class. So we'll talk a little bit about that. So a template is something that establishes or serves as a pattern. So we're going to write code with generic placeholders for type, right? So again, if I look here, it's easy to do a find replace on all this and say, well, now I'm going to make it for students. But maybe I want to make it for anything in general. So what I'm going to say is, well, I'm just going to give you that's not what I want to do. I'm just going to make it into T. T is not any type of existing class. What it is a placeholder for whatever class I want to put there. So that's basically what templating is if I make a templated class, I have a placeholder item. And basically the compiler goes through, and if I declare it of a, an instance of it of a certain type, it makes a whole new class by doing a find replace. It compiles it for you. If there's any compiler errors, it lets you know, and then you get to use it. So these placeholders are later filled in with an actual type by the compiler. The goal of templates is to write an algorithm and reuse it on different data types. Right? There's plenty of algorithms that look basically the same, except I copy the code, I paste the code, I change int for float, for instance. So in this case, the approach that we're using is we're going to have the data type as a parameter. So when I compile my code, I'm going to pass it in as an argument, essentially. So a template can be a function or a class template. And templates can be used with any data type. There's no restrictions on that. The only restriction basically is that when the compiler does the find replace on all the types, does it compile? That's it. If it compiles, then you're good to go. If not, well, then not. So you can write them however you like, assuming whatever you like, but of course, the types of functions that you call on your templated class might affect the types of classes you can use with it. So our goal is to create a function that works with any data type. Any function can be made into a template, a global function or a member function. In order for a member function to be templated, you have to have the whole class templated. So there's no such thing as a class that exists and has one templated function. Your whole class has this template. And then when the class is instantiated, again, it's not a real class, it's just a blueprint. And then the compiler does a find replace and then makes a new class for it. All right, so we're going to start looking at templated functions next class. That's it for today. So Tuesday, I guess I'll see you guys on Thursday.
Six. I got I 0 on it, or not 0, 3 out of 6. But when I ran it on my own computer, I got 7 out of 7.
Okay, just send me an email. There's something weird with the marking on that. Anyway, send me an email and I'll take a look at it.
All right. Thank you.